every data stack video serves you a fixed list, but in my experience, that's not very realistic. There is no one-size-fits-all solution, and one data stack is very specific to one project or one company or even one person. And that's why in this video, I'm going to go through 5 questions that I ask myself when I need to set up a data stack and give you for each of those answers the appropriate tool to pick. That way you don't get a fixed list, but you get to actually choose with reasons and examples of which solution is the right one for the different parts needed to make a good data stack. Let's get started. Okay, so the first question that we have is, do we want to batch our data or do you want to stream it? Which means, do we need, for instance, our data to be updated once a week, once a month, or even once a day, even twice, 3 times a day, that's fine. Or do we need live data, what we call streaming? So every time there's a change in our data, we need to be aware of it the minute it happens, because this is a fundamentally different approach, because obviously streaming is going to be more resource consuming, but it also means the tool that you're going to need for that are not going to be the same. And for that part, for batching, the best tool in my opinion is dbt, which is, very common data stack tool, especially become quite popular recently as it is quite efficient for building semantic layers in particular and works super well with also LLM and AI implementations. And I think it's just, the industry standard for most projects, because it's actually very rare that you need live data. But obviously, if you actually need to stream your data to have answers in a matter of a few seconds, then the solution that I recommend you is to go with Kafka, which is sort of the also industry standard, but for streaming. And that way you have real-time processing of data and decoupled producers, consumer views, and it's a very rich ecosystem. So those are the really 2 solid options, and also usually where you would start building your data stack. And so that's why I put that as the first thing, because defining between those 2 tools which one you're going to pick is also going to create a lot of dependencies on other tool, and making sure all the bricks that you pick can actually talk to each other and work together. So this is a fundamental one to start with. Our next question will be about the org size or number of people involved. Do you have a small team or are you part of a large organization? This is again something that is quite important to know about when you start a project, and usually something that you can already know when the project starts. It doesn't mean necessarily that when you start this team is small, you more have to think about long term. Will this be a project that is very central to a big organization? That's what you have to keep in mind, and not the initial team, but really the long term vision of the project. And if you're going with a large organization, then a classic tool would be to use Snowflake, because it has very good multi-team access and governance at big scale, and it's a super mature ecosystem, and it's also a big company themselves, so they know how that works, and it can handle really big workloads, which is going to be essential if you're going to have a lot of people look at your data. And then on the other hand, if you have a small team, then BigQuery is going to be much better, because how much you pay is heavily based on the usage. So for a small team, you're going to also pay way less, which cost is always part of the equation. It's super fast to set up, especially if you have a very small data team. You don't need that many people to figure out how it works. It's serverless. There's not any big infra that you need to manage with it. And it's quite a industry standards for startups when they first get started. So it really already does a lot, and it's really not going to limit you until you get to much bigger scale. So that means you don't have to worry for probably the first couple of years about migrating at some point. Now, our next question is something that I sort of already mentioned, but the budget cost is anything in a company, a very big part of why certain choices are made, and that's something you need to define when you start a project. Obviously, in most big corporations, you always are given a budget for a project, but sometimes I know in smaller projects, it's not really something that is by default done, especially in startups. Sometimes the approach is a bit more let's see how much it costs to do that, but actually you should always do it the other way. The cost is a frame that you need to have when you get started, and not something that you figure out, because if you think you have sort of an unlimited budget, well, you are going to use sort of unlimited money, because you're always going to go for the most expensive and easy solution, which isn't always the right choice, and also might might kind of stick you in one direction. And once the costs start rising, I'm guaranteeing you there will be a limit on the cost. And then you might have to do a lot of work to go back on those choices you made. Anyway, so two end of the spectrum have two different solutions. For high budget, Fivetran, it's again another one of those like big products, big solutions, all in one, very low maintenance, super well like monitored, can save you a lot of heavy engineering time. So if you have a big budget, go for it. It's really a great solution. However, if you're on more the lower end of budget, a fairly recent solution is DuckDB. There's even a whole like Duck ecosystem around it. It's free and open source. It has become one of like my favorite projects in the recent years. I've also worked on it and tried to implement it in a couple of projects. It runs locally, there's no cluster needed, everything's super fast. It works honestly quite well for like average amounts of data, and you're not locked in with like one vendor or one like commercial company or commercial license. And that's also very important, especially for low budget projects. It really fits super well, and it's really a product that I love. Well, it's not really a product, obviously, because it's free and open source, but yeah, it's really great. And there's now also this whole like ecosystem around it. Most like big software now have some sort of DuckDB compatibility, so you'll never have any issues with that. It's really becoming one of those like industry standard for low cost setup in data. And I'm always all for free and open source projects, so I'm really happy to always bring up DuckDB whenever I can in conversations. Okay, and moving on from the cost, we have a bit more towards the end of our data stack. What will we pick for orchestration? Doing it something very simple, just scheduling tasks, triggering pipelines at specific times, like something, very simple that is just basically a schedule? Or do we need very complex pipelines that are going to be interdependent, have a lot of like variety and a lot of heavy loads of data? Then we have two very different solutions. For the complex part, we have Dagster, which is honestly, I've had to use it once and it's fairly hard at first to get into it, but it really is so many possibility. And you can also easily scale it as your team grows, which is very nice. And there's a lot of like lineage and built-in observability, which is also really great. But at first it is a bit of a scary tool. So maybe that's a good tool to use also if someone in your team already has experience with it. But it's a really solid software. Just the approach, because it allows you to do more complex tasks, is also slightly harder to get into at first. So if you're only in need of a very simple solution, then the default answer for the past few years now is to use Prefect, because it's like a Python native app, super lightweight, super quick to set up, really easy to learn at first and to just set up. It's still fairly scalable. Actually, you can really get away with a lot as long as you have very straightforward scheduling of pipelines and orchestration. So honestly, for a lot of teams, it's actually more than enough. And yeah, really another easy tool to use and easy to recommend as well. And finally, we have what are we going to let our users see with our data, so the BI data consumption aspect. Do we need something that is a bit more self-serve, which is something that's becoming a huge trend because LLMs have allowed for self-serve to go much deeper than it used to have. Like before, you really needed to give your users almost like the queries already set, all of the data already displayed. But now with LLM sort of bridging the gap between the technical part and what users actually want to know about, self-serve is becoming a huge thing that a lot of data teams are starting to allow on a company scale. And so if that's what you're looking for, then Metabase is a really great tool. Very easy to set up, very easy to get into. And I don't know, just very simple, very straightforward UI, but works really great. And in my experience, I've seen it actually be fairly easily adopted by all kinds of users. So like it was within a company, and users like market team, sales team, all very easily adapted to it. So that's always a great sign when you're bringing sort of like a technical tool to non-technical people. I think that's very important for self-serve to focus on something that is very user-friendly. And so yeah, Metabase, very great tool. And then if you're looking for a more standard BI tool, a classic is Looker. It has a lot of implementation also with semantic layers. So for instance, in most cases, if you implement dbt, back to the first question that I asked at the start of the video, it's really easy to set up with that. There's a great setup for like data governance as well. And it's really, really easy to add new users, different teams, and kind of attribute different roles to different teams. And just very easy to scale across a big organization as well. And it really allows for like a clean look at the data, but your data team still has control over the different metric and their definitions. So also a great tool to use. It really is, in that case, a choice of what do you need, because self-serve is not always the answer. In a lot of cases, it's still more than fine to go with very standardized metrics and like sort of a dashboard approach. But self-serve is also becoming a huge trend and something that is especially interesting to start at least experimenting with, even if in the end it's not fully adopted. But there will always be in other teams people that have a bit of like a tech fiber that will want to have something a bit self-serve so that they can actually play around a bit more with the data and also take some of the workload off of the data team, because then you don't have to reply to every single request that you get about the data, and kind of give people a tool where they can ask the questions instead of it always going through the data team. And with that being said, that's the framework I wanted to show you. I really encourage you every time you start to build a new data stack for a project to kind of go through these like 5 big topics and see on what end of the like scale you are in a way. Obviously there are a lot more tools than this and a lot of like gray area that I haven't covered in this video, but it's at least to give you sort of like an easy starting point to make decisions, because you can always spend hours and hours researching every tool that exists, but usually at the end of the day what matters is getting started, and so you need to pick your tools, and this is a really great way to make the right choices but quickly enough. And with that being said, I will see you in the next video.